Good morning and good afternoon, depending on where you are. This is Patric Chang, welcoming you to the SanDisk webinar. And today we'll be talking about the all-flash versus hybrid configurations of VMware Virtual SAN for running business-critical and VDI desktop from a performance and price performance point of view. Thank you for joining us. And my name is Patric Chang. I'm a Senior Director on the Strategic Partner Ecosystem team at SanDisk. And so I will proceed and get started in a moment. And first of all, we have this usual forward-looking statement, which I'm sure you will be studying and having a look at that. And meanwhile, we'll continue to just give you a brief introduction of the speakers that we have today. And starting with myself, I work at SanDisk, and in particular, working with ISV partners like VMware to develop application solution running with our flash drive on servers and storage configurations. So I've worked in the industry, first in the server sort of a company for over 10 years, and then in a networking company for a number of years, and finally in flash storage for the last 2 years. So focusing on storage solutions for running applications and desktop. And today we are very glad to have Jack Poller, a Senior Lab Analyst from Enterprise Strategy Group, ESG, who Jack have extensive experience as well, working the last 25 years in the industry. And in addition to that, in the last 10 years, working as a marketing consultant for various storage and networking companies. And lately, he's been focusing as a lab analyst, working on hands-on validation and analysis of emerging hardware and software products, and in particular in software-defined storage. So we're glad to have Jack here today. And finally, we have Jase McCarty. He's a staff technical marketing architect at VMware. Jase have 25 years of experience, firstly as a customer, working in various verticals like the academic education, health, financial services, and so on. Previous to VMware, Jack was a V specialist at EMC, and lately he's been working at VMware in the storage BU. Jase have written 2 books on virtualization, and it's a great pleasure to have Jase here in addition to Jack today. So before we get started, just want to talk about the topics that we'll cover today. Sort of firstly with Jack Poller from ESG. And Jack will be talking about a project that the ESG was engaged in, comparing an all-flash versus a hybrid VMware Virtual SAN from a performance point of view as well as a price performance point of view. We know that we know that flash devices are more expensive, on a per gigabyte basis compared to hard disk. But the objective of this particular study is to use exactly the same configuration, with the exception of the flash devices in one configuration and a hybrid devices in another, and using a real-world application workload such as SQL Server. And Jack will share the result of that finding from ESG. And then we're going to move on to Jase. It's going to talk about some of the highlights and key features of Virtual SAN 6.0, which is an exciting release, especially with the all-flash feature. Finally, I'm going to come back and talk about some of the products that SanDisk have that has been certified for Virtual SAN, and some of the reference architecture that we have for SQL Server, Oracle, virtual desktop, and so on. And we're going to finish with a Q&A and an offer for you to get started with Virtual SAN. So please feel free to ask questions at any one time. Depending on the questions, we could take it at the end of each section, or sort of in the respect of time, we might keep moving and cover as many of those questions as possible in this session. So without further ado, I'd like to hand over to Jack from ESG to cover the first section of this webinar.
Thank you, Patrick. As Patrick mentioned, I'm an analyst with ESG, and we did some lab analysis of the VMware Virtual SAN with SanDisk, and we first sort of looked at what are the challenges facing the industry. And today, data centers are becoming increasingly virtualized. Next generation data centers incorporate more public, private, and hybrid cloud-based applications. These data centers are using virtualization and cloud, bring with it server consolidation, workload mobility, self-provisioning, multi-tenancy, and the ability to rapidly scale up and out. As organizations continue to look for ways to simplify operations, they look to increase resource utilization and improve TCO and IT. So we recently conducted a survey about IT's most important storage challenges. More than half of those surveyed said capital expenses were their most important challenge, and more than a third said operational expenses were their most important challenge. At the top of the list of storage challenges are hardware costs, the rapid growth of data, and the need to protect their data. This makes sense in light of the fact that managing data growth and improving backup and recovery, both with obvious storage implications, are among the top 5 most cited priorities in the 2016 results for our annual survey IT spending intentions. So we look at that and we say that VMware Virtual SAN presents the solutions to the challenges these data centers and organizations are facing. VMware Virtual SAN is a software-based storage solution for VMware hypervisor environments. It's embedded in the hypervisor, and it leverages standard servers to deliver flash-optimized compute and storage for hyperconverged infrastructures. In the hybrid configuration, SanDisk Optimus Ascend SSDs serve as read and write cache, and spinning disks provide the storage capacity. In an all-flash configuration, Optimus Ascend SSDs are used for write caching, and SanDisk Optimus Max SSDs provide data store capacity. Read caching isn't necessary, as reads are directly served from the capacity tier. So our test environment, which is represented here in the test bed, represents a common configuration for Virtual SAN. We had 4 servers, each running Virtual SAN 6, which aggregated all the storage resources into a virtual data store. For the hybrid configuration, each physical server was configured with 2 disk groups, and each disk group included 7 1.2 terabyte 10,000 RPM SAS drives for capacity, and then 1 800 gig SanDisk Optimus Ascend SSD for the read and write cache. For the all-flash configuration, each disk group included 2 SanDisk Optimus Max 4 terabyte SSDs for storage capacity and 1 800 gig SanDisk Optimus Ascend SSD for write acceleration. Each of the 4 servers hosted 2 virtual machines. These 8 virtual machines were running Windows Server 2012 and Microsoft SQL Server 2014. So to test this, we simulated a typical OLTP workload using HammerDB, which is an industry standard open source database load testing and benchmarking tool. The test measured performance in a typical application environment, and its actual metric was the number of new orders entered into the database every minute. So when we ran this test, we ran it for about 30 minutes, and we measured more than 1.7 million new orders per minute for the hybrid configuration. The all-flash configuration was, as you would expect, much quicker. We measured 49% better performance at more than 2.5 million new orders per minute entered into the database. So if we dig into the details a little bit, if we look at the performance per VM for both the hybrid and the all-flash configuration, the all-hybrid configuration showed some variability across the servers, but overall it was a fairly even workload distribution. As you can see, the all-flash configuration was higher performance overall and much more even workload distribution. We then looked at price and performance using street prices. We determined the all-flash solution was 10% more expensive than the hybrid, yet the all-flash solution delivered 49% better performance. When we looked at that on a price-performance basis, the all-flash solution was 20% less on a price per new orders per minute basis. So the cost for each new order per minute entered into the database was 26% less. And this reflects the price-performance advantage of a SanDisk-powered all-flash virtual SAN solution. We also calculated it would take an additional $164,000 in investment into a hybrid solution to achieve the same performance as the all-flash solution. So in conclusion, we believe that traditional IT infrastructures with various hardware and management silos limit the ability of IT organizations to quickly and easily adjust to business needs and demands. VMware Virtual SAN and SanDisk SSDs proved to be robust, flexible, and responsive, delivering major value in terms of performance, economics, improved response times, high availability, and easy administration. We firmly believe it would benefit any organization looking into an IT virtualization project to take a long look at VMware Virtual SAN with SanDisk SSDs. So now Jase McCarty from VMware is going to provide some more detail and information on VMware's Virtual SAN 6 solution.
All right, thanks a lot, Jack. Hopefully everybody can hear me okay. I'm going to cover some of the highlights of VMware Virtual SAN 6.2. Once my slide progresses, there we go. So Virtual SAN is really VMware's hyperconverged software play, if you will, in today's IT market. Hyperconverged infrastructure really leverages the hypervisor to deliver compute, networking, and shared storage from a single commodity x86 server platform. This software-driven architecture allows the convergence of physical storage onto commodity x86 servers, enabling a building block approach with scale-out capabilities. The use of commodity x86 server and storage hardware allows data centers to operate with agility on a highly scalable, cost-effective infrastructure. The foundational components of VMware's HCI solution are VMware vSphere, vCenter, and VMware Virtual SAN. They allow the convergence of compute, storage, and networking into a single integrated layer of software that can run on any commodity x86 infrastructure. vSphere abstracts and aggregates compute and memory resources into logical pools of compute capacity, while Virtual SAN, which is embedded in VMware vSphere, pulls server-attached storage to create a high-performance shared data store for virtual machine storage. Customers can further extend vSphere to achieve the convergence of networking using VMware NSX, which decouples network resources from underlying hardware and brings the operational model of a virtual machine to the data center network. Hyperconverged infrastructure leverages, again, the hypervisor to deliver compute, networking, and shared storage from a single x86 server platform. If you'll notice in the depiction here, we have a scaled-out hyperconverged solution, which is a combination of software provided by VMware as well as commodity-based hardware. Right? So this is the convergence of physical storage on x86 hardware. We can scale out through a building block approach, or we can scale up through a building block approach. We've got a lot of flexibility choosing whether we, or deciding whether we wish to choose to scale up or scale out very, very efficiently. Okay. Now, Virtual SAN is a radically simple storage platform. All right, it is VMware's software-defined storage solution. It's built from the ground up for vSphere. It abstracts and aggregates locally attached disks. We have the richest set of deployment options based on the different hardware opportunities we have, whether they be through ready nodes or some of our hyperconverged infrastructure appliances. We're deeply integrated with the VMware stack. In other words, we do not leverage a virtual storage appliance to provide storage from vSphere. We do have all-flash and hybrid configurations, and we do scale from 2 nodes up to 64 nodes. One of the things that I personally find a lot of value in, specific to the way Virtual SAN works and operates, is the fact that we use policy-based service level agreement automation, right? So with policies, we no longer have to leverage LUNs. We no longer have to individually carve up sets of disks to provide services to each of our VMs. We can custom tailor those to each of our individual use cases, our workloads. And so here's a bit of a depiction of our policy-based framework. If we notice on the left, we have 3 VMs with different levels of policies, gold, silver, and bronze. Then we have different policies based on capacity, performance, and availability. This is all tied together with storage policy-based management, or SPBM. We no longer are required to ask a storage administrator for volumes. We're no longer required to ask a storage administrator for LUNs. Virtual SAN software abstracts the underlying hardware and automates the ongoing management of storage. Okay, we are no longer required to have multiple independent storage configurations for different pieces of an individual workload. We can tie different policies to VMs as a whole, or we can tie policies to individual components within a VM. I'm going to go over a little bit more of the mechanics of Virtual SAN next. Okay. Now, we do have a minimum requirement of 3 hosts in a cluster configuration. That could be 2 hosts and a witness, providing clustering quorum, if you will. We do require that at least 2 hosts contribute storage in a 2-node configuration, or 3 in a standard configuration. We can scale up to 64 total nodes. All 64 of those may contribute storage, or only a subset of those may contribute storage. We're not required to have storage presented from each node in the cluster. Right. Disks are locally attached storage comprised of a solid-state caching device as well as a capacity device. The capacity device could be either a traditional spinning drive or it could be a solid-state device. We do require for our hybrid configurations a 1 gig dedicated Ethernet connection. And in our all-flash configurations, we recommend a 10 gig Ethernet connection, but that does not have to be dedicated. It can be shared. Depicted in the illustration here, we see we have a replica on ESX1, and we also have a replica on ESX2. That's leveraging a particular policy known as failure to tolerate of 1. This gives us the capability to have full mirrors in a hybrid configuration, if you will, as well as all flash when we're not using erasure coding. This gives us the capability of having a full data set providing for any type of failure, right? A single failure, if you will. We do require additional hosts if we enable erasure coding to align with our erasure coding strategy. Protection of RAID 5 requires 4 hosts. Protection of RAID 6 requires 6 hosts. But we've got a lot of flexibility, and again, we can tie this to a policy. Okay, now here are a couple of the options that we have. Again, I've mentioned all flash, I've mentioned hybrid. From a caching tier, we do support solid-state devices, PCIe devices, as well as NVMe-based devices. And then from a capacity tier, we support either solid-state capacity devices or we support traditional spinning drives. We've got quite a few different options available on our vSphere compatibility guide specific to vSAN. Our all-flash configurations have been tested with a single disk group providing up to 100,000 IOPS per host. With that being said, we do support up to 5 disk groups in an individual host, so that number will scale. Our hybrid configurations, we support typically around 40,000 IOPS per host with a single disk group, depending on the configuration. And again, we can also support up to 5 different disk groups, so that number will scale as well. Now, with that being said, as we expand, as we add more components to our cluster, as we add more nodes, as we add additional capacity, with a failure tolerate of 2, we do support I'll say 6 nines availability. All right, traditional hardware or typical hardware components really give us just a couple nines, right? So 3.65 days of downtime per year. Now, if we have a failure to tolerate policy of 1, then we do say we have a 5.9 protection, so less than 5 minutes downtime per year. As we add more and more components, this increases exponentially as far as availability, because we distribute the data across not only hosts, not only disk groups within the host, but also within disks within those hosts to provide a very performant as well as highly scalable and resilient platform. Now, a lot of customers have decided that virtual SAN is the platform of choice for them, and I'll get to that in just a moment, some of the particular use cases. But in the first 24 months of virtual SAN being on the market, we initially released 5.5 in March of 2014. In the past 24 years, we're now at 3,500 customers. Now, this number is 3,500 customers not only who have purchased the product, but also have deployed the product as well. With that being said, just 3 months before this, so at the end of the year last year, this 3,500 number is from about a month ago, but at the end of 2015, we had 3,000 customers. So we are growing very, very fast. Some of the different customers that you'll see, let's say Adobe, for instance, the Adobe Creative Cloud for one, some of the Adobe Creative Cloud runs on virtual SAN. So we're seeing a very large adoption rate for customers in various use cases. Now, one of the reasons why virtual SAN is really a platform of choice, a couple of the different reasons that we see here: simplicity, performance, cost, and choice. Virtual SAN is, if you're familiar with vSphere itself, you're really not required to learn any element management, for the most part. And what I mean by that is virtual SAN is very simple. If you're familiar with vSphere, then it's very easy to manage vSAN. You simply add disk groups, either manually or automatically. The system will do that for you should you choose. If you'd like to, again, provide additional performance or additional scale, you can scale up within a node or within a cluster. You can scale out also by adding additional nodes. The cost of virtual SAN is very compelling compared to some of the other, I'll say, traditional arrays, as well as some of the other hyperconverged competitors in the market. It's very easy from a cost perspective, especially depending on the use case. It's very easy to scale capacity as well as performance through the addition of additional nodes, additional drives. Quite often we see customers will go and simply add another disk group, and they'll carve up their existing disk groups and spread the capacity across multiple disk groups to get additional performance. And one of the things that I really personally find the most attractive when it comes to virtual SAN, as a former customer with 15 years in various verticals, is the fact that we have choice. And what I mean by that is let's say today my server vendor of choice is this vendor, and tomorrow my server vendor of choice is the next vendor. I can mix and match those configurations as I'm growing. As let's say I have a lease type agreement on my hardware, I can roll new servers in and roll old servers out. Gone are the days of being tied to any particular frame. And what I mean by that is gone are the days of having to go through every 3 to 5 years migrating to a new storage platform. Virtual SAN, we simply add additional hosts, and we retire the old hosts, and the data will migrate as we bring hosts online and then older hosts offline. Makes it very easy. If I decide to change my storage vendor midstream, I can very easily do, or my compute vendor midstream, I can very easily do that. That's one of the things that I really find the most attractive about virtual SAN. Now, some of the use cases that we've seen customers use virtual SAN for, I will say initially we had mentioned that virtual SAN was really we were just being conservative in saying that tier 2 workloads, test and dev, staging, that's kind of really how we initially positioned virtual SAN in the early days. But we found that more and more customers are using virtual SAN for their business critical applications, whether it be let's say, as we're speaking of today, some highly transactional workloads, possibly end-user computing such as virtual desktops. We do see a lot of customers leveraging virtual SAN for DR solutions. Test and dev, we've mentioned before. One that I find a lot of value in is demilitarized zones, or security zones, if you will. it's very difficult to have a very small footprint in a DMZ or security zone that does not require a lot of storage, and being able to properly and securely present that storage into that DMZ. With Virtual SAN, we can scale down very, very small, a 2-node or a 3-node configuration, and easily meet the needs of that particular security zone. We also see a lot of customers leveraging Virtual SAN for the purpose of a management cluster. What I mean by that is quite often customers will deploy a management vSAN cluster just for the purpose of running their vCenter, running their domain controllers, their other core services, as they do regular maintenance to some of their existing traditional arrays. It's kind of a chicken and egg situation if I have to upgrade an array that my domain controller is running on or something of that nature, right? So we're seeing a lot of people move to management clusters, if you will. And then, and I'm going to skip past staging, but also mention that Robo has become very, very attractive with some of the additional licensing that we have with Virtual SAN in Robo instances. But couple that with the fact that we can run Virtual SAN in a 2-node configuration with any one of our licenses. It makes it very, very attractive. So with that, I'm going to pass it along to Patric and let him pick up with our next section.
Thank you, Jase. Thank you for that section. Before we go that, Jase, a couple of questions that Patric can address in this section.
Okay.
You talk about the different use cases or workload for Virtual SAN, anything from business critical apps to Robo and sort of DevOps and so on. How complex is the migration process, say for your workload running in the existing vSphere environment using?
So that's actually a pretty good question. We get that quite often, and if you think about the migration process from a traditional array where we've got, let's say we've got a traditional array where we've got LUNs or we've got NFS file systems, and then we still have the normal operation of doing a storage vMotion, if you will, from the traditional array to any new array for that matter. But with Virtual SAN, we don't have the additional complexity of having to go through the sizing process. I need LUNs this size, or I need NFS this, an NFS file system presented, amount of this size, that type of thing. We don't really have the nuances specifically around, let's say I've got an older array, I've now upgraded to the newer version of that older array, and the interface is completely different. I don't have to deal with those particular challenges either. The really great thing about Virtual SAN is we can run in conjunction with existing legacy or existing, I'll say, traditional, if you will, rather is probably a better term. We can run in parallel with traditional data stores. So you can have a host that is participating in a Virtual SAN cluster, and then also leveraging your existing traditional storage. So as you decide to move your workload over, we don't necessarily have to have a swing weekend, if you will, where we move everything over at one time. We can simply enable Virtual SAN very, very easily, and then as we have the opportunity to move workloads over, we can, and then at that point we can retire our traditional array. So it's really pretty easy, and we don't have to deal with a lot of the good old-fashioned LUN and file system challenges that we would have with traditional.
Yeah, thank you for that, Jase. Another question is, do you need to buy new servers in order to run a all-flash Virtual SAN environment today?
No, you do not. No. In fact, I was just talking with a customer the other day that had some existing gear on site. They had a particular vendor platform that had quite a few drive bays and had an appropriate controller. And because of that, because their controller was already approved on the vSAN VCG or compatibility guide, all they had to do was add drives that were certified. With that being said, as far as Virtual SAN from a hardware perspective, from a vSphere side of the conversation, anything that's on the vSphere HCL or compatibility guide is supported at the vSphere level. From a vSAN level, provided the storage controller as well as the drives, provided those controllers and drives are on our VCG, that could be added to any particular host. Quite frankly, I've got 2 small hosts in my home lab that are not on the vSphere compatibility guide, but the controller that I have and the drives that I have are on the vSAN compatibility guide, so I don't have any issues with my hosts, right? So we're very flexible, whether you choose to add specific components that are compatible with vSAN itself, or you can go the ready node route, or there are a couple other options that we have specific to consuming virtual SAN.
Okay, great. Thanks for that, Jase. Just a reminder, if you have any questions for Jase or for Jack or myself in my section, go ahead and ask those questions, and we'll be happy to address that as we go along or at the end of the session. So I'm going to talk about the SanDisk so contribution to virtual SAN. First of all, look at the products that has been certified to use for virtual SAN. So we believe that SanDisk have the industry broadest portfolio of products that has been certified for virtual SAN. So if you look at the device type that we have the PCIe products, the Fusion IO memory, which are the high performance product in the market today. So those are certified to be at a class F performance. That means that they're able to deliver over 100K IOPS per second. So we have anything from 1 terabyte to a 6.4 terabyte capacity for those particular device. In addition, we have the mesh card equivalent of those. So if you want to run virtual SAN in a blade server configuration, so we have mesh card for those blade servers. In addition to that, we have the SAS drive today that has been certified for virtual SAN. So on the second row, you see the 12 gig SAS drive that we have. That is called a lightning drive. So those are certified for both caching with the Ultra and the Ascend drive, in addition to capacity with the Eco drive. And in addition to that, we have the 6 gig interfaces, the Optimus Ascend drive, and also the Optimus Eco and Optimus Max. With the Optimus Max, you can get up to something like 4 terabyte per device. So even with 2 or 3 of those devices, you get anything like with a single disk group, you can get something like sort of 8 or 12 terabyte on a node. I'm going to talk a little bit about a couple of reference architecture or vSAN ready node with those particular devices. And then for price performance, we have the SATA drive, and those go from anything from 100 gig to 2 terabyte today. So basically, all those has been certified, and we work very closely with VMware using the Virtual SAN test suite in-house at SanDisk to certify some of those products. Now, having the highest performing products for virtual SAN or what we believe the best price performance is one thing, and running synthetic benchmark on them is another aspect of it. But rather than do that, we sort of really take the kind of most popular application or databases or virtual desktop workload that people are deploying out there, and run those on those particular configurations. So working closely with VMware and our server vendor partners, we have produced a number of reference architecture with particular workload. Jack earlier talked about a project where we compare the SQL Server 2016 between an all-flash and a hybrid configuration. In another project, we use the Lenovo platform, the System X platform, and using a 4-node configuration, we were able to reach something like 3 million new orders per minute, just using a single disk group. So that is pretty capable platform for running database or OLTP database workload. In addition to that, we work with Dell on 2 reference architecture. One is a 4-node configuration using our Lightning drive to be able to host the maximum of 200 Horizon desktop per node. In fact, in our test, we went beyond that, but that is the number that VMware support and recommend. So in that particular case, we're able to start all 800 desktop at the same time, and the vSAN configuration brought up so a desktop every 24 seconds. I think within 35 minutes, all 800 were up and running. So in addition to that, in the third line, we used the exact same platform on the Dell rack servers, and we run the Oracle 12c database workload. The next one, line number 4, is with HP Enterprise. We put together a hybrid configuration, and using our PCIe card, which is, as I said, the highest performing product. And using that particular configuration, we are able to support 100 horizon view desktop per node. Now, this was completed using vSAN 5.5, which at that time can only recommended you only support 100. So we're repeating some of this project with HP, and we'll be announcing some new configurations soon. Hopefully as early as HP Discover. We also work with Supermicro using our high capacity Optimus Max product to run business critical app and VDI desktop, and I'll share that configuration with you in a moment. And finally, Dell also use our Lightning drives on their FX2 dense servers to run again a OLTP workload using the DVD store application, and they reach something like 1.1 million orders per minute using that configuration. Obviously, there's a different workload driver, which is different from HammerDB. So we don't expect exactly the same kind of numbers using that different workload. So let me just share with you a couple of the reference architecture in a little bit more detail. Just going back to my previous slide. So as I mentioned, we did a couple of reference architecture, and the previous one we did with the Lenovo using our Optimus Max as capacity, the 4 terabyte drive, and we got 3 million new orders per minute. So this one that you're seeing here is with Supermicro. So it uses 2 disk group, and each disk group, we just have 1 caching drive and 2 Optimus Max, which is 4 terabyte each. Using 2 disk group, you get something like 16 terabyte of raw capacity. When we tested this with VDI, doing a VDI desktop for knowledge workers, we are able to support 770 knowledge workers across the 4 node, and able to achieve the performance both for the CPU intensive criteria as well as the storage intensive criteria under the threshold. So again, it's a pretty simple configuration with just 6 devices per node, giving you 16 terabyte of raw storage, and being able to support 770 desktop across 4 nodes. Just want to mention that this benchmark was done before 6.2, so we did not have the opportunity to make use of the dupe and compression that's available in 6.2, but in forthcoming reference architecture, we'll turn those particular features on and see its impact on performance, as well as the ability for saving in terms of the capacity we need to provide. So as a summary, those are the reference architecture. I'm trying to go back. Those are the reference architecture we talk about. So basically what happened is we use those reference architecture, and the OEM partners then take them and have them certify as vSAN ready node. So you are able to buy different configuration of vSAN ready node using our particular drives based on those reference architecture from HP, Lenovo, Supermicro, and others. So I think we are excited and would continue to work on those new reference architecture, and we're excited with the features that are available on the VSAN 6.2 and make use of some of those new features. So as Jase mentioned earlier, there is a building momentum with vSAN adoption, and particularly with the all-flash capability that vSAN have today. So I think we can just look at one particular example of a customer that actually uses it successfully, and talk about the benefits that they have, and then we'll open up to more questions, and then close with an offer to all of you who participate in this webinar today. Hey, Jase, you want to talk a little bit about Oregon State University and how they make use of vSAN for the...
Certainly. I'll be happy to. Before I do that, though, I will say that I do see a question I'd like to go ahead and get answered so it doesn't hang around too long. And the question says, I saw 100,000 IOPS mentioned per host in one of the slides, but I also heard it is per disk group. So does it mean I would get 500,000 IOPS if I have 5 disk groups in the host? So really, just to kind of clarify that, it would really depend on the type of hardware that you have, as far as the cache devices you have, the number of capacity devices, that type of thing. But it is entirely conceivable with the right workload to see upwards of that number. I've seen customers with some very, very small configurations that were all flash that have seen peaks of 150,000 IOPS per host. So if you look at that across a 4-host cluster, that's about 600,000 IOPS off a very small cluster. Now, with that being said, that's one of the reasons why Oregon State went with Virtual SAN for their VDI environment. They found that they could boot VMs much more quickly, especially in cases of, let's say, patch management. They're recomposing desktops. They ended up getting a much greater density per host when it came to leveraging Virtual SAN in conjunction with VDI. So a lot better performance, a lot better scale. It's really easy to manage. Again, we don't have to go through the traditional, how do I carve up this LUN? Is this particular LUN, does it need to be, let's say, flash accelerated? Or, those types of conversations and those types of management tasks aren't necessarily really there anymore when it comes to Virtual SAN. We just make sure we've got the hardware, we make sure that we've got our policies in place, and it's literally just deploy, right? Because we're deploying on a single aggregated data store, if you will. Now, we do have some particular tie-ins when it comes to View, and we've got some more stuff in the works, which we can't really talk about as of yet. But I will say that the Storage and Availability Business Unit, which is the group that I work for, works pretty closely with the end-user computing group at VMware. As we bring new pieces of software to bear, whether it's vSAN 6.2 or whatever's next, we work pretty much hand in hand with the other teams within VMware to make sure that not only are we leveraging the best capabilities that they have, but that they properly and appropriately leverage the capabilities of Virtual SAN. So a couple other things I'll mention specific to Oregon State. Again, much faster, but one of the great things about VDI, and I think you covered it in a slide previously, Patrick, was the fact that we have linear performance. And what I mean by that is if we start off with, let's say, 200 virtual desktops today, and we decide that our virtual desktop use case is going to grow a particular percentage over time, we don't have to go through the traditional challenges of, let's say, doing a forklift upgrade on a traditional array that may need to be able to accommodate more IOPS. We don't have to add additional disk enclosures, those types of things. We simply add more hosts. And as we're growing VDI, we're adding new hosts as it is. When it comes to, we want to consolidate more desktops, we want to scale out, we're going to add additional hosts anyway. Couple that with the fact that Virtual SAN licensing for virtual desktops, provided you have the Horizon Advanced Suite or Horizon Enterprise Suite, Virtual SAN is included in the price, right? So Oregon State saw that and capitalized on it.
Yeah, thank you, Jase. I think we need to wrap up now. We got a few minutes left, a few seconds left. Thank you everyone for joining us today. We really appreciate your time. If you have any question, this deck will be posted, and if you have any question, please feel free to reach out to us. Thank you again, and we look forward to working with you all on virtual SAN as appropriate. Thank you. Bye-bye.
Thank you.